Americans are so used to driving that we've forgotten how complicated it actually is from a physics perspective.
This becomes even more interesting now that the electric car revolution is here.
This may sound like a pretty basic question, but do you know why a car even needs energy? Let's start by considering a car traveling on the highway. There are essentially four forces acting on it. Gravity is pulling the car down, but the ground prevents it from falling by pushing up with a force to counter the gravitational pull. As they spin, the car's tires create friction, and the force from that friction pushes the car forward. And when the car pushes through the air in front of it, we get drag pushing back.
It's because of this air drag, among other things, that it requires energy to drive a car. If there weren't any energy losses, once you got the car moving, it wouldn't require any energy to drive.
Just like a certain electric car that's currently floating in outer space. So where does this energy come from? Either gasoline, which is the old way, or a battery, which is the new way. So which way is more efficient? Burning a gallon of gasoline gets you 32 megajoules of energy in a typical compact car. That's enough to take you 30 to 40 miles. A lithium-ion battery the same size would only provide about 3 megajoules of energy. That means a car like the Fiat 500e that I drove would only get about 3 miles. But luckily in the real world, cars have bigger gas tanks and batteries. Automakers have another trick to help electric cars use that energy more efficiently.
Now, it takes energy to increase the speed of a car. We call that kinetic energy. But with electric cars, some of the energy from this motion can be put back into the battery. We call this regenerative braking. Let me show you how this works. Here I have a hand crank generator. I can hook this up to a light bulb, just like this. Now, when I turn the crank, it's going to generate electricity and light the bulb. But if you look inside, you see something that looks kind of like an electric motor. Well, what happens if I connect this to a battery? So this device in here, when you run electric current through it, acts like a motor. If I turn it, it acts like a generator. This is exactly how the motors in an electric car work to produce regenerative braking.
Normally this motor is used to power a wheel, but during braking, the motor is used as a generator so that some of the kinetic energy of the car goes back to charging the battery so that you don't lose it all.
Though you will lose some because it's not 100% efficient. You always lose some energy when you transfer from one type to another, mostly in the form of heat. That saved energy is not only good for the environment, it's also good for having a hell of a lot of fun.